Hello and welcome to day 18 of Jamb Mathematics in 30 days. It has been an interesting series so far, and I want to say a very big thank you to each and every one of you that has been following the series from day one. I'm sure you've been enjoying the series as well as we have been enjoying giving it to you too. And for those who have been following the series, I'm sure by now when you check yourself, test yourself, take past questions and solve, you are finding that you're able to solve even more questions than you could do before. And that's the beauty of this series, to make sure that you are better equipped to face JAM mathematics and come out with flying colors. Now, in this day, we're going to be looking at integration. But before we look at what it is, I would want to tell you that please don't stop telling people about JAM Mathematics in 30 days. Don't stop telling people about Oya Learn. We are here for you to ensure that your academic journey is as smooth as possible. So please keep on liking the videos, keep on sharing the videos, share it to all your friends across all social media outlets. And you can also follow Oya Learn at Instagram and also on Facebook. So to those of you seeing this video for the very first time, this is JAM Mathematics in 30 days. It's a series where when you dedicate 30 minutes to 45 minutes of your time daily, you can be equipped with every necessary tool you need to ace JAM Mathematics without a hitch. So please check out the videos from day one up until this very moment so that you can follow the series just as others have been. So check from day one to this point. You can binge watch it if you like, if you have all the time. If you have the time, please check it from day one up until this very moment. I'm sure you're going to enjoy it. I'm sure you're also going to get everything you need, and you too will go on to ace JAM Mathematics. So like I said, day 18 is about integration. And as far as JAM curriculum is concerned, what is expected of the candidates before the exam are what I've stated here. First, they expect that you should be able to solve problems on integrations that involve algebraic and simple trigonometric functions. Now, please take note of this. Most of the algebraic questions you'll face, whether it is integration without limits or integration with limits, and then for the trigonometric functions, they're going to be the simple ones that if you remember the rules in differentiation, you should be able to apply it to also find the integration. Now, take note, when you differentiate a number, a particular function rather, you get something else. Now, that answer you get, when you integrate it, it will take you back to the original function, right? So that is, if y is a function of x, say x squared, dy dx is going to give you 2x. But when you take the integration, the integral of 2x dx, this will take you back to x squared. I'm still going to show you how all of this work out when we look at the rules of integration. But this will be x squared plus a constant c. And this c can be 0, it can be any number at all. So in this case, it is a 0 because what we have is just x squared. So the same thing applies to trigonometric functions. If you know what you get when you differentiate a trig function, then you should know what you will get when you integrate it back to the original function that it is. Now, secondly, they also expect that you should be able to calculate area under a curve, right? This is a little bit of what is expected, especially in the side of applications of integration. It's one of those aspects that is rarely asked of, but we will look at it as we go on in this. So with this said, let's just go on to look at the rules of integration, and then we solve past questions from JAMB on integration. So like I said, before we can solve problems, it's always good to look at some integration rules. Now, I've mentioned at the beginning of this video that integration would take a function back to what it originally was before you differentiated it. So, and I gave an example. You have x squared and you differentiate it to give you 2x. But by the time you integrate it back, you get x squared plus c, where the c can be 0 or any other constant. Now, let's look at some of these rules that apply when you are integrating a certain value. Now, in the case where you have a function of x with a power n, as long that this power n is not minus 1, then every time you integrate it, you're going to have 1 over n plus 1 multiplied by x raised to power n plus 1. So if this were x squared, for example, it means that what we're going to get would be 1 over, remember x squared, so 2 plus 1, that will give us 3, multiplied by x raised to power 2 plus 1, which will become 3 as well. So we'll have x cubed over 3 plus constant c. So we always introduce this constant whenever you're asked to integrate without giving the limit of x. However, when you are given the limit of x, like in this case, where x ranges from b to a, so this is the lower limit, this is the upper limit. So when you integrate, you then apply when x is the upper limit, then minus when x is the lower limit. That is why you see from what we get here when we integrate, I then apply when x is a. So I replace x with a minus when x is b, right? So that's what we apply when you have upper and lower limits. Now, this also applies whenever we have other functions, like when you have integral of 1 over x. You know, this can be written as x raised to power minus 1. And I mentioned something earlier that as long as n is not minus 1, you can get this. So in this case, n will be minus 1. So whenever you are dealing with that kind of a case, that is, this same thing can be written as integral of x raised to power minus 1 dx. This is going to give you natural log of x plus c. Now I have to put this because it must be the absolute value of x, right? This implies natural log. And from when we studied differentiation, you know that when you differentiate natural log of x, it will always give you 1 over x, or x raised to power minus 1. So it's just the reverse in this case. Then when you integrate x cos x with respect to x, this will give you sine x. Just as when you differentiate sine x, it will give you cos x. So, but always remember to add plus c, because we do not have upper and lower limits. The same thing applies to sine x. So when you integrate sine x, you get negative cos x. Now, take note. We know that from differentiating cos x, you will get negative sine x. So if I'm integrating negative sine x dx, this should give me cos x. So let's test it out. You know, this would then be minus 1 integral sine x dx. This would then be, remember, from here we now have minus 1 into integral sine x dx will give you minus cos x plus c. So in this case, if you apply it, minus times minus give you plus, so we have what? Cos x. And then, of course, we always add c, so but here it will become minus c in this case. So the c in this case is 0, right? So we just get cos x back. So it tells you this rule works as well. Now, 2 rules more. There are still many others, but we're going to limit it to this. So here we have integral of sec x dx. Now, this will give you the natural log of the absolute value of sec x plus tan x. And always add the constant c. When you integrate exponential x with respect to x, it will always give you back exponential x plus your constant. So these are some of the basic rules that we need to familiarize ourselves with, so that when we're working with integration, we can always recall them. But then again, you can just go back and check the laws in differentiation as well. So anything that applied there, just know that when you're doing the reverse, it will take you back to the original function when you are dealing with integration. So with this said, let's go on now to solve some past questions in Jamb on integration. This question from Jamb 2022 says to evaluate the integral of 2x plus 1 in bracket all cubed dx. So we are integrating this with respect to x. That's just what the question means. So what we have to do here is to apply the rules of integration that we know. However, when you're dealing with a function like this, you have to be very careful with this. So here's one way you can go about it so that you do not make a mistake. So we start by saying let whatever is in the bracket, so that is 2x plus 1, let's call that u. Now, if you pay attention, that will imply that you have integral u cubed dx. Now, you cannot integrate a function in u with respect to x. So we have to find a way to write the x such that it will have the u in it. So in order to do that, what we're going to do here is we'll say du dx will then be what? So differentiate this with respect to x, and then you get 2. Now, what this implies is that if I cross multiply, I can then say dx is, that will bring 2 down here, so I'll have du over 2. So I can now rewrite this whole thing as integral. Now remember, there's no upper or lower limit. So instead of 2x plus 1, that will be u raised to the power of 3, as we see here. And then dx will then become du over 2. Now, let's integrate this. This will then be, we call out the constant 1 over 2, so integral u cubed du. Now, this would give us 1 over 2. Now, when we integrate this, we would have u 3 plus 1 over 3 plus 1 plus c. Now, what we have here would then be 1 over 2 u raised to power 4 over 4 plus c. So from here we can say that 1 times u raised to power 4 is u raised to power 4 over 2 times 4 will give us 8 plus c, which, now recalling the value of u is what? 2x plus 1. So raised to power 4 over 8 plus c. Now let's look at the options we have. Okay, 2x plus 1 raised to power 4 over 8 plus c. So we are going to pick option B. This question from UTME 2018 says, integrate 6x squared minus 2x plus 1 with respect to x. So let's solve it. So the right way to put this would say integral, open bracket, 6x squared minus 2x plus 1, close bracket, dx. And if we are to solve this, we are then going to break it down. Now, what this would mean is that we're going to be having integral 6x squared dx minus integral 2x dx plus integral 1 dx. Now, when you integrate all of this, you know this will give you plus c, plus c, plus c. So we add all those c together to get k, right? So let's go on to solve this. Now, if we're going to integrate this, we're going to have 6, then x2 plus 1 over 2 plus 1 minus 2x 1 plus 1 over 1 plus 1. This is the power. The power here is 1. Plus, now this can be written as this. Pay attention here. 1 is the same thing as x raised to power 0. So if we're going to do that, it will be x raised to power 0 plus 1 over 0 plus 1. Then everything plus k. Since this is plus c plus c plus c, we put it together and say plus k. Now, working with this, we would have 6x cubed over 3 minus 2x squared over 2 plus x over 1 plus k. Now, 3 here 1, 3 here 2. 2 here 1, 2 here 1. So what we have left is 2x cubed minus x squared plus x plus our constant. So this constant could have been written as c as well. So when we compare this with what we have here, we have 2x cubed minus x squared plus x plus constant. So the correct answer is B. So this UTME question from 2008 says evaluate integral taking limit at from 1 to 2 of 6x squared minus 2x with respect to x. Now, when we're talking about the rules of integration earlier in this video, we said that whenever you have limits, that is taking x, for example, from b to a of x raised to power n with respect to x, and you integrate this, you're going to have x n plus 1 over n plus 1, limits b and a. And then you take when x is a minus when x is b, meaning you will get a raised to power n plus 1 over n plus 1 minus b raised to power n plus 1 over n plus 1. And this is what we are going to apply to solve this problem. But before we do so, if you are yet to subscribe, please hit the subscribe button. By doing so, you are helping us to produce more helpful videos like this. And do well to also share the video and put in your questions, whatever you would like us to work on. Put it in the comment section and we'll definitely attend to all your comments. Now let's apply this rule to solve this problem. So in this case, when we integrate from 1 to 2 of 6x squared minus 2x with respect to x, this would give us the integral from 1 to 2 of, now we have to integrate all of this. So let's deal with this. We say 6x squared, right, minus integral of 2x. Remember, this is with respect to x. With respect to x from 1 to 2. Now let's solve. In this case, what we're going to have is, from here we're going to have our constant first, then x. Now this is 2, so 2 plus 1 over 2 plus 1. Remember, this is limits from 1 to 2 minus, the constant here is 2. So we're going to be having x, the power is 1, so 1 plus 1 over 1 plus 1. Limits from 1 to 2 as well. So let's start with this. From here you would have 6x cubed over 3, 1 to 2. Here you see 3 here 1, 3 here 2. Minus 2x squared over 2, 1 to 2. So 2 cancels 2. Now we are left with 2x cubed. Remember, the limit is still from 1 to 2 minus x squared from 1 to 2. Now, let's go on to apply the value of x now. So in this case, we're going to be having 2 multiplied by the upper value, 2 cubed, minus when x is 1, that is 2, 1, so this is x cubed, so 1 cubed. That's for this part. So minus, now in this case, it's going to be when x is 2, so we'll have 2 squared minus when x is 1, 1 squared. Now what do we have here? This will mean we have 2 into 2 cubed will give us 8 minus 2, 1 cubed is still 1, minus 2 squared is 4, 1 squared 1. Now 2 times 8 will give us 16 minus 2 minus 4 minus 1, that's 2. So we have 16 minus 4, and this will give us 12. So the correct answer here is in option C. This question from UTME 2008 asks that to evaluate the integral with limits of plus 1 to plus 2 of 6x squared minus 2x with respect to x. Now, before we go on to solve this, let's recall the rule of integration where we talked about it earlier. We said that when you have an integral of x and dx from a limit of b to a, what this gives you is x raised to power n plus 1 over n plus 1, still keeping the limit. And then you apply when x is a minus when x is b. So that will be a raised to power n plus 1 over n plus 1 minus b raised to power n plus 1 over n plus 1. Now this is the rule that we're going to apply in order to solve this. Now before we solve, if you're yet to subscribe, please hit the subscribe button. By doing so, you help us to be able to make more videos like this that are helpful. And also please continue to like the videos and share them amongst your friends and partners. Let them all have access to these wonderful videos that we are making here at Oya Learn. So let's apply this rule then. To apply this rule, what we'll do is now we are integrating this from lower limit 1 to upper limit 2. So first, let's integrate this. Now, when we integrate 6x squared, that will be 6x. Now, the power will be 2. Then we add 1 to that over 2 plus 1. Now, minus. What we have here is 2. Then x. So we'll have 1 plus 1 over 1 plus 1. Still keeping the limits from 1 to 2. So now we see that we're going to have 6x cubed over 3 minus 2x squared over 2 from 1 to 2. So 3 here 1, 3 here 2, 2 here 1, 2 here 1. So what this gives us is 2x cubed minus x squared from 1 to 2. So this is what we're going to apply when x is 2 minus when x is 1. So when x is 2, we're going to have, let me make that the bigger bracket, 2x 2 raised to power 3 minus x is still 2 here, so 2 squared, minus when x is 1. Now this will be 2 into 1 cubed minus 1 squared. Now this will give us 2 multiplied by 8, since 2 cubed is 8, minus 2 squared, that is 4, minus 1 cubed is 1, 1 times 2, we still have 2, minus 1 squared, that is 1. So what we're going to have here is 2 times 8, which is 16, minus 4, then minus 2 minus 1, that's 1. So this is 16 minus 5, and that will give us 11. So the correct option is D. Evaluate integral from 0 to 2 of x cubed minus x squared with respect to x. Now, what do we get when we integrate x cubed? That will be x 3 plus 1 over 3 plus 1 plus, now let's integrate x squared. That will be x 2 plus 1 over 2 plus 1. Remember, we take limits from 0 to 2. Now, here's the trick you should know. We're supposed to apply when x is 2 minus when x is 0. And when you put x is 0 in this case, you will get 0, because 0 raised to power 4 is 0, and 0 divided by 4 is still 0. 0 raised to power 3 is 0, divided by 3 is still 0. So we don't need to evaluate the part where x is 0, we just go straight to when x is 2. So this will then be x fourth over 4 plus x raised to power 3 over 3. And this will give us, so when x is 2, we have 2 raised to power 4 over 4 plus 2 raised to power 3 over 3. Now, 2 raised to power 4 will give us 16 over 4 plus 2 raised to power 3, that is 8 over 3. Now, from here we can break this, 4 here 1, 4 here 4. So what we have is 4 over 1 plus 8 over 3. And when we take LCM, that will be 3. So 1 and 3, that's 3. 3 times 4, we get 12, plus 3 here, 3 times 8, and that is, so 3 here, 1 times 8 is 8 rather. So when we add all of this together, we get 20 over 3. So let's divide. 3 will go in 20 6 times, because 3 times 6 is 18. So we have a remainder of 2. So 2 over 3. 6 whole number, 2 over 3. So the correct option is B. This question says we should evaluate the integral of cos x with respect to x, taking limit from negative pi over 2 to pi over 2. Now, here's a hint. The value of pi is given as 180 degrees when converted from radian to degrees. Okay, so which means pi over 2 is 90. And then negative pi over 2 will give you minus 90 in degrees. Okay, so we're going to work with this, taking this as degrees. Okay, so in our solution, integral from negative pi over 2 to pi over 2 of cos x dx would give us, now when you integrate cos x with respect to x, you get sine x. Now it's usually plus c, but since we have the limit here, we'll then put it out here. So this will be pi over 2 minus pi over 2. Now what we have to do is just apply when x is pi over 2 and when x is negative pi over 2. So we subtract them from each other. So what we'll have here will then be sine pi over 2 minus sine negative pi over 2. Now, but pi over 2 equals 90 degrees. So this would then be sine 90 degrees minus sine negative 90 degrees. Okay, now from here what we have to do is just find the value of sine 90. Sine 90 will give you 1 minus sine negative 90 will give you minus 1. So what we have here is minus. Now minus that 1 minus times minus will give us plus. So that is 1 plus 1, and that will give us 2. So the correct option is C. This question says we should evaluate the integral of sec square theta with respect to theta. Now, before I solve this, this is one of those very easy questions that you can just pick the options directly, right? But how you'll be able to know the correct answer without error is to recall the rules of differentiation. Now, I mentioned at the beginning of this video that when you are integrating a particular expression, what you would get would be what it would have been before differentiation. And I mentioned something like when you have x squared and you differentiate with respect to x, you would get 2x. Then when you integrate 2x, it should get back to x squared. Now, from our rules of differentiation, I did mention that whenever you have dx of tan x, what you're going to get is sec square x. So meaning that when you differentiate tan x, you get sec square x. So if I want to get tan x back, all I have to do is integrate sec square x. So from here, when we integrate sec square theta with respect to theta, what we're supposed to get is tan theta. Now, because we do not have upper and lower limits, we have to add the constant c. So the correct option to pick here is B. This question asks that we evaluate the integral of sine x plus 2 with respect to x. Now, when you integrate sine x, from the rules of integration discussed earlier in this video, integral sine x will give you minus cos x plus, now let's integrate 2, that give us 2, then x 0 plus 1 over 0 plus 1. Then of course we add our constant, so the constant here is k. So if we progress from here, we have minus cos x plus 2x over 1 is still 2x plus k. And comparing this with the options provided, we have negative cos x plus 2x plus k. So that is option D. So let's solve this problem from UTME 2023. So we have to integrate this function of x with respect to x. Now, when we integrate this, remember we have upper and lower limits. So let's start by integrating 4x. This will then be 4x with the power of 1, so 1 plus 1 over 1 plus 1 minus 6. Now, x. Now, let's come to this. What we have there is cube root of x squared. And this is the same thing as saying x raised to power 2 all raised to power 1 over 3. So what we have here is x raised to power 2 over 3. So if we work with that, it will be 2 over 3 plus 1 over 2 over 3 plus 1. Remember, limit from 0 to 1. So let's tidy this up. What we're going to have here is 4x squared over 2 minus 6x. Now, 2 over 3 plus 1 will give us 5 over 3. You can check it out. That is, we have 2 over 3 plus 1. And this would give us LCM 3. This would be 2 plus 1 here, that's 3. 3 times 1, 3. So we have 5 over 3. So that's how we got that. So, and remember from here, we'll have all over the same thing here. So 5 over 3. So we can rewrite this because 2 here 1, 2 here 2. So we would have 2x squared, right? Minus, from here the 3 can go up, and 3 times 6 will give us 18. So 18x raised to power 5 over 3 all over 5. And from 0 to 1. Now I mentioned earlier that when you are applying the value of x and you have 0, once you apply 0 for x, you will get 0 definitely. So all we need to do here is just apply when x is 1. So when we apply when x is 1, what we'll have would be 2 into 1 squared minus 18 into 1 raised to the power of 5 over 3 all over 5. And this would give us 2 minus 18 over 5. Now, when we take LCM, LCM is 5. This is over 1. So 1 and 5 is 5. 5 times 2, we have 10. Minus 5 and 5, 1. 1 times 18, that's 18. So 10 minus 18 will give us minus 8 over 5. So the correct option is B. So I would urge you to please like the video and share it with your friends. Jamb Mathematics in 30 days is still going stronger. We're going to have another day tomorrow where we'll be looking at a different topic. So please do well to hit the notification bell as well, so that when you get that video, you'll be notified and then you'll be able to check it out. See you in the next video.